Hi everyone, and welcome to our video on graphing a shifted cosecant curve. So when graphing a cosecant curve, we're really just going to graph a sine curve. So we're going to start this problem off by just rewriting it as y equals 5 sine, and then bracket 2x minus pi sixth. Okay, so all of the information stayed the same, just the cosecant curve is now a sine curve. And we're going to go through our whole process to graph this, and then the very last step is to graph the cosecant. Okay, so here we've got our a value is 5, which means the amplitude is 5, so it's positive, so no reflection. And then our b value is 2, so this is set up for us in the correct form. So in the bottom of the screen we have a different function. That one's not set up for us. We'll need to factor, but this one's nice. Okay, so here we could just keep rolling. All right, so here we've got the period would be, remember with sine it's 2 pi over whatever that value is. So 2 pi over 2. The 2's cancel here, so we would have the period is, I'm going to put it right over here, period is pi. And then the other thing is the phase shift. Okay, so the phase shift I'm going to mark in purple. The phase shift is pi sixth. So it's minus inside of that, which means the phase shift is positive. That means we would go to the right. All right, but I don't want to do that yet. I want to just do the non-shifted one. So we're going to graph our non-shifted sine curve. So sine curve looks something like this. And in previous videos I did dashed, but on this one I kept it solid because it's not the final sketch anyway. So I'm just doing a quick sine curve, and then it should go up 5 and down to -5. And we should have a period of pi, so all the way to there. And then we'll do our half times 3. So half that to get pi over 2. Half that, which would be timesing the denominator by 2, so pi fourths, and then multiply by 3, which would be 3 pi fourths, and then 0, right in the middle. Okay, so there's our sine curve. That's not shifted. Now we need to do the shifts. Okay, so here we've got our phase shifts, just labeling it, and then I'm taking my 5 important x values, so 0, pi quarters, pi halves, 3 pi quarters, and pi, and then we'll do our phase shift, which should be a plus pi sixth to all of these. So plus pi sixth, plus pi sixth, plus pi sixth, plus pi sixth, and one more plus pi sixth. All right, and then let's break those down. All right, so we've got all the equals. Okay, so some of these need common denominators. 0 plus pi 6, that one's nice. That's going to be where our phase shifted graph starts on the x. And then these others need common denominators. Okay, so let's do, I'm going to do green times this by 3 times this by 3, and that one by 2. And then let's set up all the denominators while I have the green going. So this needs to get times by 3 and 3. Here I need another 3 and another 3 and 2 and 2. And then over here, 6 and 6. Okay, so there's all the setups. And then solving these, or simplifying, 3 pi plus 2 pi is 5 pi. And then over 12. Here we've got 3 pi plus 1 pi is 4 pi over 6, which is 2 pi thirds. And then 9 pi plus 2 pi is 11 pi over 12. And then our last one, 6 pi plus 1 pi would be 7 pi over 6. Okay, so there they all are. Okay, now that we've got it, we can start to sketch our shifted sine curve. I got more room. Let's make this a little bigger. Okay, and all of the shifts are to the right, so I don't need anything to the left of the y-axis. There's no vertical shift either. Okay, so that means I could start labeling all of our stuff on the x-axis. So we're going to say, I'm going to say right here is pi sixth, and then try to evenly space 5 pi twelfths, 2 pi thirds, 11 pi twelfths, and 7 pi sixths. Okay, those are our new x coordinates to where it starts. Our sine curve got shifted over to the right by pi 6. That means it should start right on the x-axis at pi 6. And let's mark our 5 and negative 5. And then it should go to the peak at 5 pi twelfths, the upper peak, back to the x-intercept, lower peak, back to the x-intercept, just like the graph to the left. And then I am now going to do the dotted because I know I'm still doing a cosecant curve at the end of this. Okay, so there's the shifted sine curve. All right, now that we have the shifted sine curve, we go through and find all of our asymptotes. It's where it crosses the x-axis. So we've got these three asymptotes. And I'm going to label x equals pi 6, x equals 2 pi thirds, and x equals 7 pi sixths are the vertical asymptotes. And then we'll find our shared points, those peaks. There they are. And then from each peak, draw away from the sine curve to the asymptotes. There we are. Okay, so there's the completed shifted cosecant curve. Like always, we could double check if we need to. All right, so for instance, how about I plug in the 5 pi twelfths? Okay, so if I plug in 5 pi twelfths, we would have 5 cosecant of 2, and then 5 pi twelfths minus pi sixth. We would need to get a common denominator. It would simplify. Okay, so we would need to multiply that by 2 and 2. And so 5 pi minus 2 pi is 3 pi. It's over 12. Okay, here's my scratch work. 3 pi over 12 would be pi over 4. Okay, so that would simplify to be 5 cosecant of 2 and then pi over 4. The 2 and the 4 reduce. So this is 5 cosecant of pi halves. Cosecant of pi halves is 1. Yes, it matches that point up there. Okay, so you can even label it. I'm going to try to do it. There we go. Ta-da. Okay, so that checked. It worked. Okay, and we could check the other point, and we could check the asymptotes. Again, if you're ever unsure, that's what's always good about graphs. We can plug the points in and see if they actually are accurate. Okay, but that's it for this cosecant curve. So the shifted. Again, it's really just do sine and then do those last two things to finish it off. Okay, so the next one will be the secant curve. So if you want to try it, it's really just graph cosine, but we will need to factor. Okay, so that's our next video. So thanks for watching. I'll see you then.